Welcome to David Alexander Maths Tuition. This is chapter 11G where we're looking at integration using partial fractions. Okay, so let's look at our first example, which is 2x plus 3 over x plus 2x plus 3. So we've got a denominator of x plus 2x plus 3. So that reminds us of that partial fractions chapter earlier in the course. So we need to integrate this. So first of all, let's turn it into partial fractions. So sometimes an exam question will first of all ask you to write it as partial fractions. So we know that this is a over x plus 2 plus b over x plus 3. So what we're saying is that a lots of x plus 3 plus b lots of x plus 2 equals 2x plus 3. So let's let x equal -3, so that will eliminate the a. So -3 plus 2 is -1, so that's going to be -1b equals 2 lots of -3, which is -6. -6 plus 3 is -3, so therefore b is 3. So I'll just turn that b into a 3. And now I'm going to let x equal -2. So -2 plus 3 is -1, so -1a. In other words, -a is -2 times by 2 minus 4. -4 plus 3 is -1, so therefore a is 1. Okay, so what we are integrating is 1 over x plus 2 plus 3 over x plus 3. And partial fractions will often lead, if we're integrating partial fractions, will often involve turning it into luns. And the reason why here is because we've got an x plus 2 with no power attached to it, and also an x plus 3 with no power attached to it as well. So that's going to be the ln of x plus 2 plus the ln of x plus 3 plus c. And of course we can combine these two logs and we can write that as the ln of x plus 2 multiplied by x plus 3 plus c. And there we have it. Okay, let's look at another example. Now, what we're integrating here is something with an x squared on top. Now, when the power on the top part matches or is even greater than the power on the bottom, then the power on the bottom of the x's would be an x squared. This would be x squared plus 3x plus 2. So we can actually do some division first of all. So what we're doing is we're dividing x squared plus 4x plus 7 by x squared plus 3x plus 2. So let's do some division first. It will simplify this massively. So how many x squareds are in an x squared? Well, that is 1. Let's multiply this out. So 1 times x squared is x squared. 1 times, sorry, that says 3x is 3x. And 1 times 2 is 2. Do the subtraction. So that gives us x plus 5. So this stuff here is the same as integrating 1 plus this remainder of x plus 5 over x plus 2, x plus 1. So now we're just turning this part here into partial fractions, just as we did before. So that's going to be a over x plus 2 plus b over x plus 1. So we can write that as a lots of x plus 1 plus b lots of x plus 2 and make that equal x plus 5. Okay, let's let x equal -1. So that's going to be 1b. In other words, b is -1 plus 5, 4. So b is 4. And now let's let x equal -2. -2 plus 1 is -1. So that's going to be -1a is -2 plus 5, which is 3. So a is going to be -3. So what we are integrating is 1. I'll put the plus 4 over x plus 1 first. Actually, don't know why I did that, but we don't. Doesn't really matter which way around you write them. Take away 3 over x plus 2. So now this is what we need to integrate. What's the integral of 1? Well, it is x plus 4 ln of x plus 1 minus 3 ln of x plus 2 plus the c, of course. And we can tidy this up. This we can write as x plus the ln of x plus 1 to the power of 4 minus the ln of x plus 2 cubed plus the c. And because we're taking away, we can just do division. So let's combine these two logs together. So that's going to be the ln of x plus 1 to the power of 4 divided by x plus 2 cubed plus C. That's if you want to tidy it up, but you can leave it like this or like this if you prefer. So just exactly the same as we did before, except we're starting off with a little bit of division, because the power of the x on the top is an x squared, which matches, well, is not less than the power of x on the bottom, which is also an x squared. So with this one, just a bit of division first, partial fractions, and then integration as normal. Okay, so we know from the previous part of this question that we can turn this into partial fractions, which is 8 over x plus 2, take away 2 over x plus 1, plus 7 over x plus 1 squared. Okay, so, and we are we're going to integrate this. So the first part, that's just going to be 8 ln of x plus 2, take away 2 ln of x plus 1. Now, because we've got a power on the denominator here, that is not going to be, there's not going to be a ln here. So let's just write this as 7 lots of x plus 1 to the negative 2. So let's do a guess and check. So let's assume that it's x plus 1 to increase the power by 1, so minus 1. Now let's differentiate. So that would be minus 1 lot of x plus 1 to the negative 2. So we've got minus 1 and we wanted positive 7. So the sign's wrong. So my guess needs to be negative that, and that will turn this into a plus 1. But we wanted plus 7. So our guess was 7 times too small. So our guess needs to be 7 times greater. So there we have it. So it's going to be take away 7 over x plus 1 plus the c. Okay, so we can turn this into a single logarithm. So that's going to be the ln of x plus 2 to the power of 8, which is pretty substantial, minus the ln of x plus 1 squared, take away the 7 over x plus 1 plus the c. And now we've put the powers on. Now we've got rid of the numbers in front of the ln. We can combine them together. So that's going to be the ln of x plus 2 to the power of 8 over x plus 1 squared minus 7 over x plus 1 plus c. And we're done. Okay, so here's another example. Here we can't do any division though, because if we were to expand out the denominator, we'd end up with an x cubed, and we can't divide an x squared by an x cubed. So we're going to turn it into partial fractions. So therefore the f of x will be a over x plus 2 plus b over x plus 1 plus c over the x plus 1 squared. Okay, so what that means is that's going to be a lots of x plus 1 squared plus b lots of x plus 1 x plus 2 plus c lots of x plus 2, and that is going to equal the 6x squared plus 17x plus 18. So if you've not understood what's gone on there, then you might need to check out the partial fractions section. I can't remember if that's in year 12 or I think it's at the beginning of year 13. Okay, so now let's let x equal -1. So that will eliminate the a and the b. So that will give us what's a value for c. So -1 plus 2 is 1. So that is c. And so c is going to be equal 6 times -1 squared, which is 6, minus 17 plus 18. 18 take away 17 is 1 plus 6 is 7. So c is 7. Okay, now let's let x equal -2. So that will give us the a. It will eliminate the b and c. -2 plus 1 is -1. -1 squared is 1. So that will tell us that a is, okay, so let's just be careful here. So it's 6 times -2 squared plus 17 times -2 plus 18. So a is 8. Okay, so a is 8. And now to work out what b is, I'm just going to let's go for let x equal 0. So 0 plus 1 squared, that is 1 squared, which is 1. So that's 1a. So a plus, so 0 plus 1 is 1. 0 plus 2 is 2, so 2 times 1 is 2 plus 2b, and 0 plus 2 is 2, so plus 2c equals 6x squared when x is 0 will be 0, 17x will be 0, so equals 18. Right, we know that a is 8, we don't know what b is, and we know that c is 7, so 2c is 14. So therefore 2b is going to be 18 minus 14 minus 8, so 2b is negative 4, so b is negative 2. So what we have is 8 over x plus 2 plus negative 2, or just minus 2 over x plus 1 plus 7 over x plus 1 squared. So this is presumably what we're going to be integrating for the next part of this question. Okay, so we know from the previous part of this question that we can turn this into partial fractions, which is 8 over x plus 2, take away 2 over x plus 1, plus 7 over x plus 1 squared. Okay, so, and we are we're going to integrate this. So the first part, that's just going to be 8 ln of x plus 2, take away 2 ln of x plus 1. Now, because we've got a power on the denominator here, that is not going to be, there's not going to be a ln here. So let's just write this as 7 lots of x plus 1 to the negative 2. So let's do a guess and check. So let's assume that it's x plus 1 to the increase the power by 1, so minus 1. Now let's differentiate. So that would be minus 1 lot of x plus 1 to the negative 2. So we've got minus 1 and we wanted positive 7. So the sign's wrong. So my guess needs to be negative that. And that will turn this into a plus 1. But we wanted plus 7. So our guess was 7 times too small. So our guess needs to be 7 times greater. So there we have it. So it's going to be take away 7 over x plus 1 plus the c. Okay, so we can turn this into a single logarithm. So that's going to be the ln of x plus 2 to the power of 8, which is pretty substantial, minus the ln of x plus 1 squared, take away the 7 over x plus 1 plus the c. And now we put the powers on. Now we've got rid of the numbers in front of the ln. We can combine them together. So that's going to be the ln of x plus 2 to the power of 8 over x plus 1 squared minus 7 over x plus 1 plus c. And we're done. Okay, so we know from the previous question that when we integrate this, we end up with the ln of x plus 2 to the power of 8 over x plus 1 squared minus 7 over x plus 1. Okay, and the limits are 2 and 0. So let's do our two brackets. Okay, so the ln of 2 plus, so let me just write this down. That's the ln of 2 plus 2 is 4. 4 to the power of 8, unfortunately, is going to be a very big number. So that's going to be the ln of 65536 over 2 plus 1, which is 3 squared over 9. And that fraction can't be simplified. Minus 7 over 2 plus 1 minus 7 thirds. And now let's put 0 through this. That's going to be the ln of 2 to the power of 8. 2 to the power of 8, which is 256. And that's the denominator will be 0 plus 1, which is 1 squared, which is 1. So that's just ln 256. Take away 7 over 1, so take away 7. So there we go. Let me make that 7 a little bit bigger. Okay, so what we've got is ln of 65536 over 9, take away 7 thirds, minus ln of 256 plus 7. Okay, so what we can do minus 7 thirds plus 7. So minus 7 thirds plus 7, that is 14 over 3. So B is 14 and C is 3. And we are subtracting one log from another. So what we can do is divide 65536 over 9 by 256. So let's just type that back in, 65536 over 9, divide that by 256, and we're getting the ln of 256 over 9. There we go. So A is 256 over 9, and well, it seems a bit odd that A has not been written as A over something else, but unless I've made a mistake, it should be 256 over 9. So A is a fraction, 256 over 9, and B is 14, and C is 3. Now, this all seems fairly questionable, but what I would do is turn this into a decimal on your calculator. What do you get? And then type this integral into your calculator using the limits of 2 and 0, and do you get the same answer? If you do, you know you've got it right. If you don't, you know you've got it wrong, unfortunately, but at least that tells you to go back and give it another go. Keep hacking away until you eventually get the right answer. Okay, let's look at this final example here. Now, the fact that we're showing that f of x equals a plus some partial fractions, this a tells me we can do some division. So if I expand that out, that's going to be 4x squared minus 1. That will go into 16x squared plus 2. How many 4x squareds are in 16x squared? Well, that is 4. 4 times 4x squared is, of course, 16x squared, and 4 times negative 1 is minus 4. Let's do a subtraction. 2, take away negative 4, positive 6. So we know that this a here is 4. And the remainder is 6. So what we have is we've got 6 over 2x, well, we've got 6 over 4x squared minus 1, or 4 over 2x plus 1, 2x minus 1. So what I'm going to do is turn this into partial fractions. Normally I'd use a and b, but because in the questions we've got b and c, I'll use b and c. So that's going to be b over 2x plus 1 plus c over 2x minus 1. So what we can say is that b lots of 2x minus 1 plus c lots of 2x plus 1 equals 6. So let's let x equal positive 1/2. That will eliminate the b part. Half of 2 is 1, 1 plus 1 is 2, so 2c is 6, therefore c is 3. And now if I let x equal minus 1/2, then that will eliminate the c part. So minus 1/2 of 2 is minus 1, minus 1 minus 1 is minus 2, so minus 2b equals 6, so therefore b is negative 3. There we go, so we are done. We have shown that this the f of x is 4. Take away 3 over 2x plus 1 plus 3 over 2x minus 1. So from the previous question, we know that the f of x was 4 minus 3 over 2x plus 1 plus 3 over 2x minus 1. So what we need to do is just integrate this. So the integral of 4 is 4x. The integral of negative 3 over 2x plus 1, well, if I think it's the ln of 2x plus 1, if I were to differentiate that, I'd get a 2 on the outside, and I want a 3, so I need to multiply that by 3 over 2. So it's going to be minus 3 over 2 ln 2x plus 1, and next one's going to be plus 3 over 2 the ln of 2x minus 1, and that is between the limits of 3 and 1. Now, just to tidy things up a little bit, I'm going to combine these logs. So first of all, you might want to write it as 4x plus 3 over 2 ln 2x take away 1 minus 3 over 2 ln 2x plus 1. And we can then rewrite that as 4x plus 3 over 2 ln of 2x minus 1 over 2x plus 1. And we don't need to worry about the plus c because it's a definite integral. Okay, so what's this going to become? Let's put 3 through it first. So 4 times 3 is 12 plus 3 over 2 ln of 6 take away 1 is 5, and the denominator will be 7. That's right. Let's put 1 through the function, so that's going to be 4 times 1, which is 4, plus 3 over 2 ln of 1 times 2 is 2, take away 1 is 1, and on the bottom that will be 3. Okay, so what we have is 12 plus 3 halves ln 5 over 7 minus 4 minus 3 halves ln of 1/3. Now 12 take away 4 is 8, so that's 8 minus 3 over 2 lots of ln 5/7 minus ln 1/3. And if I just move this final answer up here, sort of run out of space, we can write that as 8 minus 3 over 2 ln of 5/7 divided by 1/3, which is 15 over 7. Okay, now what we need to do now, just to double check we've got this right, is we'll get this as a decimal and then just go back to, well, grab our calculator and just put this into our calculator in the integration, or just integrate that on your calculator and just double check that the decimal equivalent of 16x squared plus 2 over 2x plus 1, 2x minus 1 between the limits of 3 and 1 is exactly the same as the decimal equivalent of 8 minus 3 halves ln 15 over 7. And as long as they match up, we know we've got it right.